In July 1994, the world watched in awe as a shattered comet hurtled toward Jupiter, triggering explosions so powerful they dwarfed Earth itself. What happened next changed our understanding of cosmic collisions forever. Sure. Here's a detailed account of Comet Shoemaker-Levy 9's collision with Jupiter, structured into 5 long chapters but presented as a continuous narrative. In March 1993, astronomers Carolyn and Eugene Shoemaker, along with David Levy, peered through their telescope at the Palomar Observatory in California and stumbled upon something extraordinary, a fragmented comet unlike any they had ever seen. It appeared as a string of pearls stretched across the sky, broken into pieces by an immense gravitational force. This discovery ignited a sense of urgency among the scientific community, as calculations soon revealed that the comet was on a collision course with Jupiter, the largest planet in the solar system. Such an event had never been observed before, and its implications were both thrilling and ominous. Shoemaker-Levy 9 had once been a single, intact comet until it ventured too close to Jupiter in the early 1990s. The planet's immense gravity, a force 2.5 times stronger than Earth's, captured the comet and stretched it apart into more than 20 fragments. Instead of escaping, the comet became a captive of Jupiter's powerful grip, doomed to spiral toward its demise. Scientists around the world braced for what would be a once-in-a-lifetime cosmic spectacle. The collision was set to occur in July 1994, giving astronomers over a year to prepare their telescopes and predict the extent of destruction this encounter might unleash. As the impact date approached, telescopes from Earth and space turned their attention toward Jupiter. Observatories across the globe, as well as the Hubble Space Telescope and even the Galileo spacecraft en route to Jupiter, stood ready to witness history in the making. The anticipation was palpable, as no one had ever seen what happens when a celestial body crashes into a planet. Would the fragments simply vanish into Jupiter's thick atmosphere? Or would they produce visible scars, explosions, or some other unforeseen consequence? The answers were only days away. On July 16, 1994, the first fragment, labeled A, plunged into Jupiter's southern hemisphere at an astonishing speed of 60 kilometers per second, nearly 134,000 miles per hour. The impact was not immediately visible from Earth, as it occurred on the far side of the planet, but within minutes, infrared telescopes detected an enormous fireball rising above Jupiter's cloud tops. The heat generated by the collision was immense, reaching temperatures exceeding 24,000 Kelvin, hotter than the surface of the Sun. Scientists were awestruck as they realized the power behind this impact. Over the next 6 days, fragment after fragment struck Jupiter, each impact creating a massive explosion equivalent to millions of nuclear bombs. Some of the larger pieces, such as fragment G, delivered energy equal to 6 million megatons of TNT, far beyond anything humans could ever conceive of producing. Dark scars, each larger than Earth itself, appeared in Jupiter's atmosphere, lingering for weeks and serving as a haunting reminder of the devastation. The planet's normally banded appearance was now marred by ominous, inky black bruises stretching across its face. The scientific implications of the event were profound. By studying the impact plumes, researchers gained valuable insights into Jupiter's atmospheric composition, revealing previously hidden layers of gases and complex chemical interactions. The collision also underscored the destructive power of celestial impacts, offering a stark reminder that if a comet of similar size ever set its sights on Earth, the consequences could be catastrophic. Shoemaker-Levy 9 had provided a glimpse into the raw, chaotic nature of the cosmos, an unforgiving realm where even a gas giant like Jupiter was not immune to destruction. In the aftermath of the event, astronomers continued to study the scars left by the impacts, tracing how Jupiter's atmosphere slowly healed itself over time. Within months, the dark spots began to fade, absorbed by the planet's swirling storms and turbulent winds. But the lessons from this dramatic encounter remained. Scientists redoubled their efforts to track near-Earth objects, aware that the same fate could befall our planet if an undetected comet or asteroid were to head our way. Shoemaker-Levy 9's collision with Jupiter was not just an astronomical spectacle, it was a sobering reminder of the fragile place Earth occupies in the universe. It proved that cosmic impacts are not just theoretical possibilities but real, tangible events with far-reaching consequences. The discovery, prediction, and observation of this event marked a turning point in planetary science, reinforcing the importance of vigilance in monitoring the skies. Jupiter, with its immense gravity, had once again played its role as the solar system's guardian, shielding the inner planets from catastrophe. But the event left one lingering question in the minds of many. What if the next one isn't caught in Jupiter's embrace? Shoemaker-Levy 9's collision with Jupiter was a wake-up call, a glimpse into the raw power of space and the dangers lurking in our solar system. If such an impact happened on Earth, would we be ready?